Ionization energy. What exactly is it?
Well, if you search up ionization energy online, you may find this graph. And yes, I will admit that it looks very intimidating, but after watching this video, I'm sure you will be able to read this graph just as easily as I can.
Well, in the big picture, it is the amount of energy that is needed to take an electron out from an atom to form a positively charged ion. However, of course, there are more steps along the way. But before we dive deep into the topic of ionization energy, here are some key elements that you must know beforehand. So a lot of these, many of you may know and learned in class, so this is mainly just a recap. So every atom has a nucleus, and the nucleus is formed by protons and neutrons. And the electrons surrounding these nucleus has a very strong attraction to the nucleus, and also orbitals, and we'll mainly be focusing on valence shells, and this becomes a very key point in our topic on ionization energy. So here's a periodic table that has some important information about ionization energy. So from this version of the periodic table, we can indicate that as you increase a period, so from hydrogen to helium or lithium to beryllium, the ionization energy is increased. Well, the reason is because as the atomic radius decreases, it becomes much harder to remove an electron that is more closer to a positively charged nucleus. Conversely, if you go down a group, so hydrogen to lithium or lithium to sodium, the ionization energy decreases. And, well, this is because another valence shell is added, and these valence electrons are much further away from the nucleus, making it having a weaker attraction. So let's look at potassium, for instance. Potassium has 4 orbitals and 1 electron on its valence shell. And this ionization energy to take out that last electron for potassium to become stable like argon, the ionization energy is much lower than sodium or calcium because it is only needed to remove 1 electron. However, if you have more than 1 electron in your valence shell, what exactly happens? So let's look at boron, for instance. Boron has 2 orbitals and 3 electrons on its valence shells. Well, if you have more than 1 electron on the valence shell, there is a specific process you must follow. And this process isn't a very complicated one, it's rather very simple. So the ionization energy process for more than 1 electron on the valence shell is that you start with an electron with the lowest energy. So when that electron with the lowest energy is taken out, then you move on to the next electron. And now this electron needs to have a little bit more energy to be taken out because now the nucleus positive attraction is not only divided by 3, but now divided by 2, making a more stronger attraction. So then once that is taken out, then you take out the next electron that is needed to have more energy, and then so on and so on. So here we have the ionization energy graph, and it is the same graph we have seen before, but with this new information, it is not as intimidating. So with our new information that we have figured out, it is much more easier to tell what this graph is trying to tell us. So we can see in the very first element that is hydrogen, and that only has 1 electron and 1 proton. And then it goes to helium, and the ionization energy needed to take 1 electron away from helium is spiked way up there because helium is a stable element. It's a noble gas. And it is basically impossible to take an electron away naturally. And now you drop down a group to lithium. And now the ionization energy to take away an electron from its valence shell is spiked way down, or should I say, drops very low. And then you head to beryllium, and then the ionization energy increases little by little until it hits neon, which is, again, a noble gas, and heads way back down to sodium. And this gradually continues on for as long. And well, there you have it. Ionization energy is told in the most simplest way that I can imagine. Thank you.